What is an inverse function in investigation? 1. Consider the function 2x plus 4. A. Explain why the function has an inverse function. Well, it has an inverse function because it's a straight line and it's not a vertical line and it's not a horizontal line. It's a one-to-one function. B. Complete the table for the function and for the inverse function. Okay, so what was given in the book was just these black numbers here. And I needed to fill in the red numbers for the function, and I put the blue numbers in for the inverse function. This is our function. They gave us minus 4, so you put minus 4 in there, you get minus 8 plus 4 is minus 4. That's the x value, that's the function value. This is a notation we're going to use. It's a mapping notation. You put an x in, which was minus 4, and a minus 4 comes out after you put it through the function. The right-hand side is the function value or the y value. The left-hand side is the x value. So you put those x's in, you get those y's. You represent it like this. Then you actually write the points, because if that's the x value and that's the y value, that's a coordinate point, and we can write it down as minus 4, minus 4. 1 and 6 is 1 and 6. Now in some of these things, they gave me the y value, so I had to work backwards. So when they gave me 0, that's the y value or the function value. It's the left-hand side. So 0 equals 2x plus 4. Therefore, x must equal minus 2. So I wrote the minus 2 in here. Let's look at the inverse function now. So this is describing the inverse function. Now we're using this mapping notation. For a certain value of y, you put it in the inverse function and you get a value of x. Now x is represented as the inverse function of y. That's how it's represented. Because as we saw previously, what this represents is that for a certain value of y, what is the x? When y is minus 4, what's the value of x? Okay. For this one here, when y is minus 2, what is x? So we put minus 2 in here. So if you put minus 2 in for y, then x must be minus 3. Because minus 3 times 2 is minus 6, plus 4 is minus 2. In this case here, when y is 4, what do we get for x when we put it through the inverse function? When that is 4, x has to be 0, because if the left-hand side is 4, this term must be 0 because 4 equals 4, right? The right-hand side has to equal 4. The only way for that to happen is if x is equal to 0. That's how we got those. Now, I think this is a bit tricky, this next step here. These are coordinate points. And the coordinate points are normally written x and y. Okay, that's when we actually put it through a function. For example, here, we're told that's x and that's y, so we write x and y. X and y, that's x and y. But there's a bit of a difference when we jump between these two. And to understand that difference, it's probably better to call one the independent variable and one the dependent variable. In this case, these are the independent variables. Okay, they're the independent variables. They always go on the left. They're those. That's why these are, even though it says y there, this is not yx. This is the independent variable on the left and the dependent variable on the right. That's how the coordinate point is represented. So try not to think of it as x and y. We should think of it as the independent variable on the left and the dependent variable on the right, the independent variable on the left and the dependent variable on the right. Another thing to keep in mind as we proceed through this investigation is that this should make sense to you because it's what you've been doing for years based on that function. This is a little bit difficult to comprehend because we're not actually doing it through the inverse function. We haven't seen what the inverse function looks like yet. You haven't seen what it looks like yet. What is the inverse function of this function? So we're basing all our numbers here on the original function. So that's a bit complex, isn't it? It's a bit hard to kind of get your head around. But it's coming up and we'll be able to see what the inverse function, how it is represented in the form of y equals mx plus b. Okay, C. The points E and E dash have already been plotted on the given set of axes. Okay, I've added the red and the blue lines, but they had E dash and E. They plotted those. Now I've copied and pasted this one. That's for the function. This is for the inverse function. Now their point E was 1, 6. So they already had that place there, 1, 6. Their point E dash in the inverse function was 6 and 1. So it's 6 and 1. It said draw the graph of that function 2x plus 4. Also clearly plot and label the other 5 points on the graph of f that were found in part B. Okay, these are the points here. So I just plotted those and I've got the line. Now the line looks right because it's 2x plus 4. It's got a y-intercept of 4. It has a gradient of 2, which is basically 2 over 1. It's got a run of 1 at the bottom and it's got a 2 on the top, so 2 over 1. It's got a rise of 2 and a run of 1. So that's our line. That's the function. Plot and label the other 5 points on the graph of the inverse function that were found in part B. So there's your E dash. I've added A dash, B dash, C dash, D dash, and F dash using those coordinate points, and that is the inverse function. We can represent it on the graph as well. D, what can you say about the type of graph that the inverse function is? Well, it's linear. How would you find more points on this graph? Well, you can just estimate points, look for intersecting grid lines, and you can, maybe that's a point there, 8 and 2, for example. Write down at least 3 more points on the graph of the inverse function, then complete the inverse function graph. Well, that's completed. That's there. E, what can you say about the position of the point B dash with respect to the position of the point B? So they want you to compare that point and that point. And what about the position of C dash with respect to C? And then you've got C and C. What's the relationship? Now, this is the key to what an inverse function actually is. What do you notice about that C and that C dash and that B and that B dash? Let's have a look at the points. B is minus 3 and 2, and B dash is minus 2 and minus 3. Okay, so in fact, that's happening to all the points. If you hadn't noticed already, we've got, for example, point C. It's minus 2 and 0, but C dash is 0 and minus 2, so they've reversed. So basically, a point on this line, the coordinate points, the actual x and y values, have swapped positions. So this one here is minus 2 and 0, and this is 0 and minus 2. So what else do we notice? For example, C and C dash, they're both at the corners of that box. So if you join the line between C and C dash, it would be 45 degrees to the x-axis and off 45 degrees to the y-axis. And the same here. Look, if we look at D and D dash, if you join the line between those two, it would cut through that point, and it's 45 degrees to the x-axis as it cuts across the x-axis, and as it cuts across the y-axis, it cuts across at 45 degrees as well. So we've got to think about, what is that relationship? If we knew this function, could we draw the blue function without these coordinate points? Is there a pattern? F. There is one point that lies on both graphs. What is it? Well, it looks like A and A dash, right? It's the same point. What do you notice about the coordinates of this point? Well, the coordinates of that point, it's very interesting. It's minus 4 and minus 4 for the function, and because it's the same point, it's minus 4 and minus 4 for the inverse function. So it says, what do you notice about the coordinates of this point? The x and y values are the same at that point. They're the same. This point also lies on the line that bisects the first and third quadrants, the identity line. Now, that's not a very common definition of that line. You often see it as the x equals y axis, not identity line. In fact, it's interesting to Google those two words and see how many hits you get in mathematics, right? So it's generally known as the x equals y axis. What is the equation of this line? Well, as we just said, it's the x equals y axis. So along that line, the x values and the y values are all the same, as we saw with point A. So if you extend it all the way up here, 6, 6 is on that line, 8, 8 is on that line, 10, 10 is on that line. Draw it with a dotted line on the set of axes. Okay, there it is. It's not so much a dotted line as a dashed line, but that's the y equals x axis, and that's the line that they call the identity line. Draw it with a dotted line. How would you describe the positions of the graphs, the function and the inverse function with respect to the identity line? Well, these points are now equidistant from that line. They're equidistant, aren't they? So the f to that line and that line to the f are equidistant. And also we talked about joining lines up between these two. If you join up between D and D dash, it's going to cut this green line perpendicularly at 90 degrees. That'll do exactly the same. Now G. Now explain how you would draw the graph of the inverse function. Well, how would you draw it? Well, if you've only got the red line, and we know that the y equals x-axis is an important element of constructing the line of the inverse function, then what you would do would be you would reflect the point across that line. So if that C is that distance away from that point of the green line, that's that far, you put it over here. So if D is there, you cross the line the same distance. It's that distance, and you cross it to here. So it's a reflection across that line creates the inverse function. And it says H, what is the equation of the inverse function? Well, we can get the equation of the inverse function from this, but graphically, we know what it's going to be, right? It's crossing at -2, so for y equals mx plus b, if it crosses at -2, we know it's going to be y equals mx minus 2. The slope is 1, a rise of 1. It's a positive slope still. It's a rise of 1, and it's a run of 2. So that means the equation of the inverse function is this. Okay, we said m is a half because it's got a rise of 1 over a run of 2, and it crosses the y-axis at -2. So that blue equation there is the equation of the inverse function. 2. The diagram shows the graph of a function g. Some points on its graph have already been marked. So they've got those points already there. Explain why g has an inverse function g to the -1. Because it's a one-to-one function. B. Complete the table. Function. Okay, if we're just looking at this function, which is g, the domain is the x-axis, so the domain is from -2 to 4. So x is greater than and equal to -2 and less than and equal to 4. The range is y is greater than or equal to -4 and less than or equal to 5. Okay. Now, okay, and it says complete the table, so we need to fill this in, but for some reason we can't actually see that graph yet. It says draw the graph of the inverse of g. You may use those points and the identity line. Well, we'll do that first. We'll put the identity line down. Okay, so I've drawn the identity line, which is the y equals x-axis, and all I need now is to transpose these points. Might as well you do the extremities here, so why don't we do that? Okay, so I've transposed the points. That's our now A dash, B dash, C is on the line. So both the function and the inverse function pass through that point, and that's D dash. Let's connect those. I've effectively reflected the red line across the green identity line, or the y equals x-axis, to the blue line. The blue line is our inverse function. We can now fill in the table because we can see now for the inverse function, the domain is from -4 to 5, and the range is -2 to 4. And this brings us now to the end of the investigation, and have a look at those two, the factual and the conceptual questions, and think back of what we just covered. But this is important to remember. The domain of the inverse function is the range of the function. So the domain of the inverse function is the range of the function. Okay, that's the same. They just swap. The range and domain will swap between the function and the inverse function. The range of the inverse function is the domain of the function. So the range of the inverse function is the domain of the function. And that's really interesting.